So last class we have seen permutation. So number of permutation of n distinct objects taken r at a time without repetition is p n r. So it has the value n factorial by n minus r factorial. So that is n into n minus 1 etc. n minus r plus 1. So let us see a few examples in today's class. Okay, so the first problem is, so let E equal to set of all A, B, C, etc. x, y, z be the set of 26 English alphabets. So find the number of 5-letter words that can be formed from E such that the first and last letters are distinct vowels and the remaining are three distinct consonants. So let us see how to form a 5-letter word. So you need to form a 5-letter word such that in the last two places you have vowels and in this 3 places you have consonants. So the vowels are A, E, I, O and U. So there are 5 vowels and 21 consonants. So let us see how to find the number of permutations. So there are 5 vowels and 21 consonants. E. So the first and last place you need to arrange with vowels, and in the 3 places in the middle you need to arrange with consonants. So any distinct vowels venam. So we can divide the whole problem into 2 steps. So the first step is choose a 2 permutation from A, E, I, O, U and put that in the first and in the 5th position. And the second step is you have to choose a 3 permutation from 21 letters and arrange that in the 3 positions in between. Okay. So നമുക്ക് ലാസ്റ്റ് 2 പൊസിഷൻസിനെ ഒരു ഗ്രൂപ്പായിട്ട് കൺസിഡർ ചെയ്യാം, മിഡിൽ പൊസിഷനെ വേറൊരു ഗ്രൂപ്പായിട്ട് കൺസിഡർ ചെയ്യാം. സോ ബൈ യൂസിങ് ദ മൾട്ടിപ്ലിക്കേഷൻ റൂൾ, so the product of both will be the number of ways. So the problem has 2 steps. So the first is fill in the first and 5th position with distinct vowels. So this can be done in which can be done in so you have 5 vowels in total. So out of that you need to arrange 2 objects in the first and the 5th position. So this can be done in 5 P2 ways. And the second is arranging 3 distinct consonants in the remaining 3 positions. So this can be done in, so you have 21 consonants, so out of 21 you need to arrange 3 objects at a time, so that is 21 P3. So now by using the multiplication principle, so required number of 5-letter words will be so that is equal to product of this two, so that is P52 into P21 3. So when you take the product, you will get 1596, that is 0. So that is the required number of ways. Let us see another question. So the second problem is, so there are 7 boys and 3 girls in a gathering. In how many ways can they be arranged? In a row, so that the first condition is, so first subdivision is 3 girls form a single block, and the second subdivision is 2 end positions are occupied by boys and no girls are adjacent. So there are total, so let us do the first part. So there are 7 boys and 3 girls. In the first part, 3 girls must form a single block. So since 3 girls form a single block, it is like arranging 7 boys and 1 single block. Appam 3 girls in a single block aayittu consider cheyumbo, so it is like arranging total of 8 objects. So നമുക്ക് 8 objects arrange ചെയ്യുന്ന പോലെയാണ് വരിക. So 8 objects can be arranged in 8 factorial ways. Now when you arrange the girls inside the block, they can be arranged among themselves in 3 positions in 3 factorial ways. So by multiplication principle, the required number of ways will be 8 factorial into 3 factorial. Okay. So since girls are arranged in a single block, the problem can be considered as the number of ways of arranging eight objects among themselves, so which can be done in, so that can be done in 8 factorial ways. So which can be done in 8 factorial ways. and the 3 girls form a single block, and in the block they can be arranged among themselves in 3 factorial ways. So therefore the required number of arrangements, so therefore it is by multiplication principle. So by multiplication principle, the required number of arrangements, so that will be the product of this two. So we will get 8 factorial into 3 factorial. So we can find out the answer. So the calculator edit final answer item. So let us see what is the solution of the second part. Now in the second part, the 2 end positions must be occupied by the boys and no 2 girls must be adjacent. So let us first arrange the position for boys. So boys, there are 7 boys. So B1, B2, B3, B4, B5, B6 and B7. So these will be the 7 positions in which the boys are arranged. That can be done in 7 factorial ways. So arrange all the 7 boys first. So they can be arranged among themselves in 7 factorial ways. In n position boys arikkanam. The girls can be seated in any of these 6 positions. So n positions random boys ayadonde girls in the possible positions girls adjacent aavadilla, appo possible positions can be 6 positions. So in this 6 positions 3 girls has to be arranged. So that can be done in P6-3 ways. So that is 6P3 ways. So 6P3 will be, so you get 6 factorial by 3 factorial. So that is 6 into 5 into 4. Now take the product of this by using the multiplication principle. So we will get the required number of arrangements. So let us write that together. So let us first arrange all the boys. So they can be arranged among themselves in 7 factorial ways. Now the girls cannot be seated adjacent so and the 2 end positions must be seated with boys. So therefore the 3 girls can be seated in the 6 positions, so which can be done in P3 ways. So therefore required number of arrangements is so that is equal to, so you get 7 factorial into P6-3. So that is the required number of arrangements. So that is 7 factorial into 6P3, 6 into 5 into 4. So find out this value. So that is the required number of arrangements. So Okay, so we'll stop with that for today's class. So we'll see few more problems in the next class.